Hey everybody. Today we're going to walk through a distributive law part 2 lesson. So what we want to do is we want to kind of bring back some of the stuff when we covered distributive law for the first time. And then what we're going to do today is we're going to extend it a little bit with some of the new algebra skills that we have. So I put up on your screen that I want us to recall. I'm hoping that problem looks familiar to you. Earlier in the year, we had to go through and find the area of an entire garden. And so, as we recall, we had the option to take a look at that. First off, recognize that I could view that garden as one big box, or I could view it as two smaller boxes. And so we could calculate the area of any rectangle by one dimension times the other one, or length times width. So we had the option to say, well, let's go through and calculate the area of the whole thing at one time. And so we took one dimension and we multiplied it by the other dimension. And if we were going to view that as one big garden, then all the way across the bottom of that garden, we have a dimension of x plus 6. We hit a snag there because we didn't really know what to do, and if we try to follow BEDMAS, we can't do the addition inside the brackets because what we have are unlike terms. So, what could we do otherwise? Well, then we examined taking that garden and breaking it up and viewing it as the two smaller gardens we see. And so maybe we said that we have like carrots in the first garden. And maybe we said that we have like corn in the second garden. I don't know. But then that would have allowed us to calculate the area of each individual garden and total them up in the end. And so we could have went through and said, well, the area is my carrot garden, which is 5 by x, plus the corn garden, which was 5 times 6. And then we can do any operations we can do there. We can calculate the 5 times 6, but we cannot add to that the 5x because we have unlike terms. And we saw that those two things were equal. And so there must be a way to make those equal. And that's where we learned about our distributive law. And that is where we learned that if we need to expand our brackets, that is, if we need to do the multiplication operation when we can't do the addition operation, then we can just take whatever monomial is out in front and multiply it by everything on the inside of the brackets. Okay, that was a quick review of our distributive law. Now, let's jump back to a little bit of review that's a little more recent. So, what you see on the screen now, quick instruction to simplify, and you have a relatively straightforward expression, 3x times 4x squared. I want to give you a moment to work through that one on your own. So, I want you to come up with the simplified form of that expression. Okay? Pause the video and give it a shot. Pause it now. Okay, we're back. And so hopefully we were tackling that operation by saying I can simplify my coefficients. So I can do the multiplication between the numbers, calculate whatever I can. And now I take a look and notice I have a power of x times another power of x. And if we're multiplying powers of the same base, we can add those exponents. Or you say you have 1x times 2x's. There's my 3x's or my x cubed. So hopefully we got down to that same point and things are looking pretty good. What we're going to do for the rest of today is we're going to throw those two ideas together. I don't know if we're quite ready for it yet. Let's work through a couple more examples of some of the more difficult stuff that we saw before. Okay, so what you see on the screen now, there are two examples where we have been given the instruction to expand and then simplify. And so what I would like you to do is to give both of those problems a shot. I'd like you to try both. Pause the video. Try them. Unpause it, and let's come back and see if we match up in the end. Okay, give A a shot. I want you to pause the video now. Okay, we're back. So, as a little bit of confirmation, I'm going to go through and do all of my expanding work in purple and all of my simplifying work in red. So I take a look at that and I notice that I cannot collect what is inside those brackets. Those are unlike terms. And so I can then do my multiplication by taking my 2 and multiplying it inside the brackets. That's going to give me a 6x minus 2. You'll notice I'm done on that problem. To follow the instruction to simplify, that is fully simplified because I cannot collect those two terms. They are unlike terms. So nice. Problem 3A, one-step problem. Okay, I'd like you to work your way through B. So let's do the same thing. Let's pause the video and give it a shot. Okay, pause it now. Okay, we're back. So clearly when we take a look at this problem, it's more complex. That is, when we take a look at all the operations, you notice that you have a multiplication between the 3 and the brackets. You notice you have another multiplication between the 6 and the bracket, and we are subtracting those two things. You'll also notice that inside the brackets, we have a subtraction and we have another subtraction. So if we were to go through and simplify that expression, I have all of those operations to maneuver. So the first thing I need to look at, those purple subtractions. Can I subtract my unlike terms? No. So I cannot do the purple first. That means that with the operations I have left, my multiplication, my subtraction, BEDMAS says I have to do the multiplication first. So I am now going to expand in that 3 and that 6. So if I expand in my 3 into the first bracket, I'm going to get a 3m minus 9. And this is where you want to be very careful. The value that I am going to expand into my second bracket isn't just the 6, but it's also the negative 6. And so when I expand in that negative 6, I'm going to get negative 6m, and here is your trap. There is a negative 6 times a negative 7. There's my plus 42. And if I was to look around the room and take a poll, I'm going to bet that if we made a mistake on that problem, that will be your most common problem, most common mistake. Okay, there was my purple line. I have gone through and I have expanded that. But now I notice I can simplify what I have. I take a look and I have two terms that contain an m. I also take a look and I have two constants, two numbers, no variables. So I can collect all of that stuff. So I'm going to collect that. I'm going to simplify in red. That is, I can take my 3m and subtract my 6m. That's going to get me a negative 3m. And be very careful here. I have a minus 9, and then I add 42 to it. So I am hoping that we come in on a positive 33. If we made a silly mistake there, we need to just check that, but let's make sure we're not making an integer mistake. Take a look at your two constants, negative 9 and plus 42. If I collect those, if I lose $9, but then I find 42, I'm up 33. So let's make sure that we're not making any numeracy mistakes and we can clean that stuff up. Okay. That would be a full review of everything that you were responsible for expanding and simplifying back in cycle 2. Now's where we're going to take a look and see where we go with this. So I would like you to take a look at the screen in front of you, and you're going to notice that stuff looks pretty similar. However, there is a change. And so what I'd like you to do is just to try problem A on your own. Okay, do not attempt B, do not attempt C, not yet. This is one where I would like us to work through A, and then we're going to come back and we're going to check and see how well we do. Okay, I want you to pause the video, give it a shot. Okay, pause it now. Okay, we're back. So, what makes this problem different than all the expanding that we were doing before? Well, you might have noticed that in your term out in front of the brackets, that monomial that's attached by multiply, you have a variable there. Maybe you've never noticed before, and it might not really have been the sort of thing you gave a lot of attention to because it's all we knew. But all the problems that we did before only just had a constant out in front of those brackets. So look at the previous examples on this page, and if you have an organized binder, flip back to the last time we did expanding. You'll notice it was always a constant out in front of your bracket. Well, you notice I changed that a little bit on this problem. I now have a variable attached to that. Okay, is that a difference? Yes. Is it a meaningful difference? It really shouldn't be. I take a look at that problem and I go through the same process. The first thing I look to do the operation inside the bracket. Can I subtract 3x minus 4? No. So if I can't do that, then I move on to that next operation. There is my multiply. And I can expand a 2x into my brackets. So I'm going to take that 2x and I am going to multiply it by 3x. Now you might see why this is some new material for us, or at the very least, it's us combining a few ideas. You simplified that expression on a previous day. You would have taken 2x and you would have multiplied it by 3x. And hopefully we look at that and we do it in 2 steps. Deal with your coefficients, 2 times 3 is 6. Deal with your variables. X times x is x squared. Notice that was from our multiplying monomials day. So what we're doing now is we are incorporating that skill. Okay, I'm going to get rid of that purple because I'm going to work that into my solution. So I take my 2x times my 3x. There's my 2 times 3 and my x times x. And now I need to expand that 2x times my negative 4. Well, that one's a little more straightforward. That one's going to get me a 2 times 4. There's my 8. And I have a single x in that term. So if we expanded, great. We got our 6x squared minus our 8x. And we should be finished. The instruction that says to simplify, we notice we cannot simplify that expression because, again, I have unlike terms. Okay, one little side note. If you've gone through that exact same process as what I just described, you tried to do the operations inside the brackets, then when you couldn't, you expanded, then you know that that expression that you got when you expanded will not simplify. Because the only way it could simplify is if you could have simplified it earlier, and we couldn't. That's just something to use as a little check. We'll pop in with that as we go through the next problems. Okay, even with just going through that first problem, I think you may be ready to tackle the next 2 on your own. So here's a case where if you're feeling super comfortable, tackle both. If not, then maybe you're just tackling B on your own. You come back, give it a check, and then we tackle C on our own. Okay, but right now I want everybody Pause the video, give B a shot. Okay, pause it now. Okay, we're back. So, same process. I take a look on the inside. Can I subtract those two terms? No, I cannot. So, now I do my multiply. So, I'm going to take my negative 4a and I'm going to multiply it into everything inside the bracket. Okay, I've got my negative 4a times 5b. So, deal with your coefficients. Negative 4 times 5 is negative 20. Deal with your variables. A times b is fully simplified. So there is my AB. And now I need to multiply it into the last term inside my brackets. So now I'm going to take my negative 4a and I'm going to multiply that by negative a. Be very careful. A negative times a negative gives me a positive. And I've got my 4a times a, so there is my 4. And my a times a gives me an a squared. We notice again, we cannot simplify. If we could have simplified, we would have been able to simplify up top, and you notice you cannot. Okay, now it's time to give C a shot. I want everybody to pause the video now and give it a go. Okay, pause it now. And we're back. Okay, what makes this one a little more difficult? I shouldn't even say a little more difficult. It's not more difficult. It's just more. We notice that we have 3 terms inside the brackets. Nothing changes. We take a look inside our brackets. Can we do any of those operations? No, because we have unlike terms. So I'm going to take my time and I'm going to be methodical. And I am going to multiply my coefficient into every term. Okay, negative 3m times m. Well, there's a negative 3 times 1, which is a negative 3, and an m times m is my m squared. Now, I have my negative 3m times negative 6b. Okay, you guys already got better versus the previous problem, and we're not making the mistake. A negative times a negative is a positive, good. And then I deal with my numbers and my variables. So my 3 times 6 is my 18, and an m times a b is simply an mb. Now, small little note, if you recall, good form and a great habit to get into is that when we have variables in one term, we like to write those variables in alphabetical order. Okay, it is good form, but it's also going to help us to be able to identify like terms. So rather than writing that as MB, I'm going to write that as BM. And now, if any other terms with an M and a B pop up, they're going to be easier to identify as like terms. Okay, last step. Take my negative 3m, multiply it in times my c. That one should be a little bit quicker. We get our negative 3. An m times a c in alphabetical order will give me cm. There we go. So you take a peek at those 3 problems. Take a look at those 3. Try those 3 again if you need to. Those are going to become the small basics of where we go. Okay, when you're ready, we're going to jump into the last set of problems. Okay, you see on your page question D, E, and F. And by the time we take a look at E and F, those are starting to look considerably uglier than what the previous problems did. Okay, here's where we're going to check our understanding a little bit, and here's where we're going to try to stretch ourselves. I would make the argument to you that if you are comfortable to work through E and F, I don't think there's going to be anything we throw at you in your practice that you will not have difficulty with. Okay, Let's take a look at D, and we're going to give all of these a shot on our own. Okay, pause it now. Okay, we're back. So you take a look at D, and D probably looked unusual to you. It's okay. If we follow our process, we follow bed mass, we're good. You take a look inside your brackets, you see you have a subtraction operation. You cannot subtract, but you notice that you have that multiplication operation between your two brackets. So I need to take that multiplication and expand in my my negative 4x to everything inside the bracket. Okay, I've got my x times negative 4x. That's going to get me a negative 4x squared. And then I have my negative 3 times negative 4x. Well, I have a negative times a negative, which is a positive. And 3 times 4 is 12 with that x. Okay, I would argue that if you were good to tackle D, then that's showing you understand how we can use distributive property. You have a pretty good grounding in how to multiply monomials. And if I switch up the order on you, that didn't change the way you tackled the problem. We could recognize what we saw in front of us. So that should give you really good feedback as to where you're at with D. Okay, we're starting to get into the doozies. So I want you to give E a shot. Remember the instruction. Expand and simplify. Okay, give it a shot. Pause it now. Okay, we're back. Now, if E was, let's say, a test question, say that was an evaluation question, I would want to see the solution in 2 steps. Let's be slow, let's be methodical. Quickly, look inside every set of brackets. I can't collect those, I can't collect those, I cannot collect those. So, I take a look at my next operations and I notice I actually have 3 multiplications. So, let's take them in their bits. Slow and methodical. 3x times x gets me my 3x squared. 3x times negative 4 gets me a negative 12x. Slow and methodical. You take your time. I take a look at my next multiplication and I notice that I have a negative x that I'm going to expand into my next set of brackets. So I multiply that times x. There is a negative x squared. I multiply that times positive 5. There is a negative 5x. Slow and methodical. We notice our next multiplication is expanding in a negative 2x. So now I have a negative 2x times an x. There's a negative 2x squared. And now my negative 2x times negative 1, well, a negative times a negative is a positive. And there we go. I think if you have that first purple line, that's giving you some great feedback and you're doing well. Last thing we need to do, collect all of our like terms. Well, I'm quickly going to just go through and notice that I have an x squared term, another x squared term, and another x squared term. And if I go to collect all of those x squared terms, I notice they cancel out. I have a 3x squared, and I need to subtract 1x squared. Well, that gets me 2x squared. But now I need to subtract off another 2x squared. And so those all cancel out. Please do not write 0x squareds. 0 times x squared is 0. What some of you may like to do is when you simplify, you may say, well, those cancel out. And that may make it a little bit easier in your solution. So the only thing that I have to put together are my single x terms. I have A negative 12x, subtract 5 more, gets me to negative 17. Add on 2 is going to get me to a negative 15x. And when we collect that whole thing up, that's what we get down to. Very nice. So if you're able to get down to there in our 2 steps, I think that's telling you you have everything you need. Okay, last problem for today. Let's give F a shot. Pause it now. Okay, we're back. So we've got some uglier expressions inside the brackets, but we're going to take our time and look at our operations. Inside each set of brackets, you notice it is already fully simplified. You do not have any like terms, so we do not collect. Now we're working our way through and we are expanding in all those coefficients. So slow and methodical, let's expand in that 3x to everything. Slow and methodical, let's expand in the 2 to everything. If we got stumped a little bit by the ugliness of the expression, I'm going to say, let's pause it now that you got an idea. Give it another shot. Okay, pause it now. Okay, we're back. So I should be able to go through and expand in all those values just for confirmation. 3x times 2x is a 6x squared. 3x times negative y is a negative 3xy. 3x times negative 1 is a negative 3x. Now I'm expanding in my positive 2. So 2 times xy, 2 times 4x, and 2 times 5. Okay, we take a look across that purple expression, and you notice you do have a few like terms. You have this xy term and this other xy term, so we could collect those. And you have a single x term and another single x term. We could collect those. So we do have a little bit of simplifying to do. There are no other like terms with the 6x squared. When I put together the terms I circled in green, I have a negative 3xy plus a 2xy. So if I lose $3 and I find 2, then I'm down $1. Please make sure you do not write a coefficient of 1. That is bad form. Now I collect the orange circled terms. I have a minus 3x plus an 8x. So if I lose $3, then I find 8. I am up $5. And then I have no other constants in the expression. So I still have that plus 10 that cannot collect. And there we go. Okay, I want you to look over the whole lesson for today. Take a peek at everything we've done. Notice we started off with a little bit of review. If we struggled with some of that review, you might want to take a look back into Cycle 2 stuff and get a little extra practice with that. If you were fine with the problems at the end, that's our current cycles material. Then your job now is to jump in and start knocking out some practice and making that as automatic as possible. Okay? Best of luck, guys.